In this lecture, we're going to zoom in on different kinds of iterators or categories of iterators we can have in our C++ programs. I am going to use the piece of documentation here on iterators at c++.com. If you want, you can come to this place and follow along. So they are going to say that an iterator is any object pointing to some element in a range of elements has the ability to iterate through the elements of that range using a set of iterators. We saw that we could use the ++ operator to move forward in our iterators or move backwards if we are using a reverse iterator. This is possible. We also saw that we could go through the dereference operator to get access to elements inside our container. So iterators are designed to really behave like pointers. You see, with pointers, we can use the ++ operator to do pointer arithmetic. We can use the dereference operator to get what is pointed to. So iterators are really built to be like pointers, but not all iterators support the same features that we have with pointers. Some iterators are limited, and the features of an iterator are somewhat hinted to the type of the iterator. So let's look at different kinds of iterators we can have in our C++ programs. We can have input or output iterators, and an input iterator is an iterator you can use to read things from a container, and what you get from the container has no connection whatsoever to the original data in the container. So what you get is really a NAR value or a copy of what you had in the container. This is what an input iterator is. An output iterator can be used to put data back in a container. So what you get from an output iterator, if you dereference it, is going to be a null value, which is really going to be like a reference or a pointer to the original data in the container. And this is what they are trying to say here. Another thing you should know about input and output iterators is that they don't have the ++ operator, so you can't really use them to move around. They are somewhat limited, and in my almost 10 years as a C++ developer, I haven't really explicitly used an input iterator in my C++ programs. Another kind of iterator we have is a forward iterator, which can either be input or output depending on whether the iterator is const. But the defining feature of forward iterators is that they can move forward in a collection. They have the ++ operator. A bidirectional iterator can move either forward or backwards, so it is really much more flexible. And a random access iterator is not even going to require you to do all the kinds of incrementations we are doing to move from one place to another. You can go through some kind of offset to decide which element you want. So in a container with a random access iterator, you can say, I want the element at index 5. You're going to get it right away. You can say, I want the element at index 22. You're going to get it right away without doing all of the kinds of incrementations we are going to do to hunt for our element of interest. So random access iterators are pretty powerful. If we go down, we're going to see different operators that each kind of iterator supports. Input iterators support the equals and not equals operator, so you can compare them. They can be dereferenced using the operator here, but if you dereference them, what you get is going to be an R value. You should really know this. So it is going to be some kind of copy with no connection whatsoever to the original data in the container. But an output iterator can do the same things you can do with an input iterator, so you can read from a container and get a value. But you can use what you get from dereferencing an output iterator to change the data in the original container. So what you get is really a reference or some kind of a pointer to the original data in the container. And this is what you see here. We can say dereference A and assign in a value, and this is going to work really well. So another kind of iterator is a forward iterator, which is really going to have the same features we have in input and output iterators. But a forward iterator will allow us to use the ++ operator to move forward in our collection. This is what we can do with a forward iterator. A bidirectional operator can even be decremented, so we can either move forward or backwards. So it is much more flexible. And on top of a bidirectional iterator, we have a random access iterator, which is really much more powerful. So you can increment the iterator, you can decrement the iterator, but the most defining feature is that we have random access through offsets that we can add to a given iterator. So you can say, I want the element at this index, and you're going to get that right away. And that's going to work really well. So these are offsets we can use. For example, you can take an iterator and add n. You can take n and add an iterator. You can compare these iterators. You can add an offset through the compound addition and subtraction operator. You can even use the array index operator to really specify which element you want at a given index in the collection. This is going to work really well. One thing you should know is that these iterators englobe each other. So a forward iterator is going to contain the features of an input or output iterator. A bidirectional operator is going to have the features of a forward iterator, and a random access iterator is going to be having the feature of a bidirectional iterator. So if you have something that requires a forward iterator and what you have is the random access iterator, that's going to work because a random access iterator is also a forward iterator. So these things work like an inheritance hierarchy we have seen in classes in C++. You should really know this. Another kind of iterator we have starting from C++ is a contiguous iterator. And this iterator is going to guarantee that the data that the iterator points to is stored contiguously in memory. This is really what we can achieve with contiguous iterators. And if you happen to come across them in your career as a C++ developer, you should know what they mean. So any kind of iterator you will meet in your career as a C++ developer is going to fall in one of those categories. So it is either going to be an input iterator, which you can use to read from a container. It is either going to be an output iterator, which you can use to put data back in the container. It can be a forward iterator, which you can use to move forward in a collection. It can be a bidirectional iterator you can use to either go forward and backwards. And we can do this because we have these kinds of operators here. We have a plus plus operator we can use to increment the iterator to make it to move to the next element. And we can use the minus minus operator to move it to the previous element. We have this flexibility here. We also have a random access iterator, which is really on steroids because it's going to allow you to do all kinds of crazy things. But the most defining feature is that we can use the enough setting mechanism to directly specify the element we want in a collection. This is going to allow us to use an array index operator and specify that we want, for example, an element living at a given index, and we will get it right away. So a random access iterator is going to have the features of all the other iterators we have seen before. So it is going to also be a bidirectional iterator because you can increment and decrement it. It is going to be a forward iterator because you can make it move forward. It is going to also be an input iterator because you can use it to read from a container, and it is going to be an output iterator because you can use it to put data back in a container. But in practice, you don't need to put in all these operators and really be crazy about this. Just make sure that you have the operators you want to do whatever it is you want to do with the container where the iterator is defined. That's how you should go about this. Now, in C++ 20, we also have a contiguous iterator, which is going to guarantee that the data that the iterator is iterating through is stored contiguously in memory. And if you happen to need this kind of memory locality, contiguous iterators are going to be your thing. So this is really how you should think about your iterators. We have input and output iterators. Forward iterators are going to contain the features we have in input and output iterators. Bidirectional operators are going to have the features we have in forward iterators. Random access iterators are going to be much more powerful because they will have the features of bidirectional operators, but they will also allow us to do some kind of offsetting to get data we want directly using indexes, and this is really cool. Contiguous iterators are going to be much more powerful in that they are going to require for the data that the iterator is pointing to be stored contiguously in memory, and I want you to be aware of these things. So any kind of iterator you will use in your C++ program is going to fall into one of these categories, and you need to be aware of this. This is all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see another way you can get hold of iterators you can use in your C++ program, and that's through std_begin and std_end methods. Go ahead and finish up here and meet me there.